we prepare for future habitat on the moon.
On the moon, yeah.
And it came out that the moon was the best destination to test many of these technologies for deep space. First baby will be born on the moon, possibly 2040.
Do you believe in time travel?
People, they like this conspiracy, so we...
So Bernard, I want to ask you, what do you do in space?
Yes, so I've been working at the European Space Agency for more than 25 years, where I worked on missions to study the sun, and then I studied stars. I studied also then the moon, Mars. I had experiments on the International Space Station, and also I was looking at molecules in the universe, and so some of the ingredients that was brought to Earth to create life. So it's let's say I'm a space scientist, a space engineer, but also I became a manager. I was heading the research division at ESA, and also I was chief scientist and advisor to the director general. Even then I moved to topics like representing the community of 1,400 colleagues as the chair of the staff association for 6 years. So I went from science topic, engineering topics, to people topics. And I have left ESA now, and I created a new agency. Actually, it's a set of initiatives now where we are developing, for instance, training and careers for young professionals to go into space or to benefit from space. So this is called the Eurospace Hub. It's a consortium with the various universities in Europe, also with some NGO and some industry. And we have a program now where we train space researchers, in particular in analyzing data, in particular in the forum here block. We have some of my collaborators and students analyzing data from Earth observation, applying machine learning scheme, artificial intelligence to get some value out of the data. We have also a program where they train to technology, space technology, instrument, and also because we are interested also by expansion into deep space on the moon and Mars, we test those instruments on the moon and Mars with experiments that flew to the moon and Mars on a mission like Smart One, which has led, but also Mars Express, also international missions. But before we go to Mars, we test them in places on Earth that look like the moon and Mars.
So we are prepared for that.
So we are prepared. So we are building also. So for instance, we have a campaign on Etna volcano, now, which is active. We have a campaign in Hawaii, in places that look like the moon and Mars. In addition, we started a program 15 years ago called Your Moon Mars, where we train analog astronauts to go living on a moon base or a Mars base, a moon village, and we lock them for some time in the base, and they perform research activities like we will do in the future. So this led as well to develop some concept of habitats, and for instance we have built some habitats that are now operational in Poland, operational also in Hawaii on Mauna Loa volcano. We are also now building a mobile habitat in Europe that will move from city to city to share with the researcher, with the public, what we do to prepare for space. And more recently, 5 years ago, we also started to integrate business into this, so to develop opportunities for startup making use of observation data or instrumentation or even astronautics experience to develop some new services and new careers.
You know, this channel is called Astropreneur. I'm so happy to hear that you're saying that you want to attract more startups, because I think that space business is a huge thing, and in the future it's something that's gonna help us so much in the whole space exploration, space development. So this is incredible initiative.
We have to invest from the business side, but also I want to have some revenue that I can invest in the research side to develop a knowledge-based society, and also share space with all the public, because I think all public, we are citizens from spaceship Earth, so they have all to be trained as well.
You know, you mentioned here the habitats that you're having in different places, and I recall my visit to Japan.
Mm-hmm.
I was attending the Moon Village Association conference. So it was Moon Village Association forum, or how do they call it?
Yes, every year we have
exactly.
an event like this. The first one was at the International Space University a few years ago. Then we had in Japan, we had in the US, and we are returning to Japan this year.
Oh, that's a good opportunity for me to visit Japan again. I love that we've been in Tokyo, we've been to Kyoto, and also we were lucky enough to visit Mountain Fuji.
Yes.
We went into lava tubes to be prepared for the moon mission.
So you can join our group of analog astronauts. Actually, also I have been collaborating with Japanese colleagues that prepared Kaguya mission, so mission that was launched in 2007 to the moon. So I was part of their science team, and also we had various workshops in Japan, and we went under Mount Fuji again, also to test the instrument in the lava cave,
yes.
which are also places where we prepare for future habitat on the moon.
On the moon, yeah, exactly. Wow, this is so interesting. So you're also known as father of the Smart One project that you've mentioned previously, and this is for me super exciting because it was the first European mission to the moon, and question here, the findings that you got out from this project, how did it influence the general perception of the humanity to the moon, and also the general understanding about the moon and what is the potential for the future development there and exploration?
Yeah, indeed, Smart One, small mission for advanced research and technology number 1, was the first mission of the program to develop small missions with a low cost in a fast time and with advanced technology, and so we developed it in a 3 years time scale, while all other missions were developed in 10 years. So we had intense small team working with industry, taking some risk, but also using support from the technology side, also some new way of doing business, new way of also organizing a quality for space project. And it was also done in preparation for future mission, more ambitious, that we had to prepare from the technology side. And then for this mission, we asked, where would be the best target to test all those technologies? And it came out that the moon was the best destination to test many of these technologies for deep space. And some others said, also at the moon you can do big science, also you can do big technologies, or test new ways of working together. So we developed the Smart One mission in a 3 years time scale. It was at the time when Professor Roger Bonnet was the director of science at ESA, and so we.
It was in 19.
So we launched in 2003. We had some precursor studies from 97 to 99. And only in 99 we got the go-ahead for the budget, which was about 90 million euro. So we made also low cost, and we could build the spacecraft in 2 years and a half. And just to arrive to do that in such a time scale, we did it also with the Swedish Space Corporation. We helped them to develop a bit also their know-how in terms of building satellite. Even just to put the spacecraft on top of the rocket, which was actually Ariane 5 rocket, we used share the launch with other telecom passengers. I think we had done already 50% of the work. But then the other part of the work was to go from there to the moon, and there we are testing some new technologies. One of them is solar electric propulsion. It's a technology that allows you to travel from space to space using 5 times less fuel than chemical propulsion. And actually this technology can help us to go into deep space, to destination like Mercury. We are using this technology, or to Mars, and but also it's used now for application satellite to save a large part of the fuel to circularize the orbit of geostationary satellite from the geostationary transfer orbit. And so it has also big economic application, but sometimes you develop new economical solution also by doing fundamental research and technology. So it was Smart One. So we were there, and so we developed a mission that was only a 350 kilogram spacecraft, only 60 liters of fuel to go from Earth to the moon. so much more efficient than your car, I suppose, but a large distance. Actually, we entered in the Guinness Book of Records for the most efficient mission going into deep space. But the point that the technology we used was also special, so you create some plasma, these are so ionized particles, you eject at very high speed, and then by reaction you push your spacecraft. But at any time, the force you exert on the spacecraft is what we say 70 milliNewton, so it's the weight of three pages of this paper, and you push a 300 kilogram spacecraft. So, but if you are patient, if you push for 6 months, your spacecraft is going to have a speed even faster than if you push it with big chemical energy. So that we did, but it took us to go to the moon 1 year and a half. So we had the second Guinness Book of Records, the slowest mission to the moon. While if you do it with chemical propulsion, it takes you 5 days, like in the time of Apollo. But what we did is we used this cruise on the way to the moon to learn to navigate, to surf. So we could say we got our driving license of driving a solar electric propulsion vehicle, but also we tested all the instruments during the cruise. We observed the Earth already when we were getting further, beautiful planets, and then we arrived at the moon. And finally, after we arrived at the moon, we had a 1 year and a half of orbit around the moon to do science and exploration. And as you mentioned, it was the first ESA mission to the moon. Actually, it was the first lunar mission of this millennium in 2003. And then we had to wait 2007 to get other countries like China and Japan with their own mission. And then there was another launch of a Chandrayaan-1, an Indian mission that followed 2 years later. But because we were the first and lonely at the moon in 2004 and 2005, everybody looked at us. We shared our data with the whole world.
You were the pioneers.
We are the pioneers, and also we exchanged collaboration opportunities, and we built also a platform of collaboration and peace with many other countries. So now, after this, we arrived at the moon, and we had small instruments. And so, what is the legacy? So we made some maps of the poles of the moon in particular, and we found some places which are in eternal shadow, very cold, like minus 200 degrees Celsius. Others we found a peak where there is always almost sunlight, and where everybody wants to go now. We measured also some compositions of the mineral there, and also at the end we had a controlled impact we could observe from Earth. So all this allowed us to create some database for future exploration, but also a network of collaboration that led to prepare the next step, which will be a robotic village of landers and then a moon village with humans.
This is all incredible. Do you believe in time travel? Because I do, and I want to bring you back and to ask, like, how did it all start and when did it all start? Did you just wake up one morning and said, I want to explore moon? Or how did you come up with an idea that moon is such a valuable resource that need to be explored?
So, question on time travel, astronomers, they do always time travel, because when you observe stars or galaxies, you observe the light that was emitted in the past. For instance, we can observe the Big Bang, which was 13.7 billion years ago. So we do all travel in the past. Actually, also, when you look at your body, what makes your body, you can tell me, how old am I? And I'm 13.7 billion years old, a bit older than you, because the hydrogen in our body was created at the Big Bang. The carbon, the nitrogen, the oxygen was created in the center of stars. So we always do time travel. But now in a more recent time, actually my passion for space came from my childhood. So when I was a child, we went in the summer, we would sleep outside, look at the stars, and I wanted to become an astronomer. Also at the same time, I came from a family that was affected by the war. So at the same time I said I want to become a diplomat to stop the war. At the end, I became an astrophysicist, and I work in an international organization where I became a science diplomat. So
Yeah.
I did the
You
two.
do both, and this
I do
is
both.
incredible.
And we use, for instance, so space to develop new technologies, science that you share with the world, and you can also develop space diplomacy.
This April, basically on 3rd of April 2023, NASA has announced the 4 astronauts of the Artemis 2 crew, the people who are gonna fly near the moon after like more than 50 years since Apollo mission, right? And for me, it's very interesting, and I think for many people as well. But why do actually people want to go to the moon?
Yeah. So.
What's the reason behind?
Okay, so there are different things. Okay, so these are good colleagues, and I think it will be some of the envoy of humanity going on this Artemis 2 mission. So they will go around the moon, and actually it's a great challenge for us as a collaborative project. As you know, Europe is contributing a significant part of this project, because the capsule is built by the US as the Orion capsule, but Europe is building a European service module that is inheriting some of the technology we developed for project automated transfer vehicle to the space station. So very intelligent system with propulsion, with power, and this will bring this capsule around the moon and then back at the right angle for a safe entry. So it's a great opportunity for the joint project. Now, the question of why we go to the moon. So there are answers why we go to the moon from the point of view of what you can do with robots also there, like we did with a smart one. So we can go there to have some data of scientific value, to develop some technology, to develop a peaceful collaboration, but also to prospect for future resources. And future resources include some material resources that we have discovered on the moon. We found water ice, we found some elements with metal you can extract, and then in the future you can manufacture product on the surface of the moon. And another aspect, we are going to go there also for the best resources we can harvest. What is it? Human creativity. You can go there to inspire the public. Young people say, yes, we are part of this Earth-Moon double system. Our future is partly there. We are going to benefit from that. Oh, we want to study science, technology, or even art, innovation, to prepare ourselves for the challenges of our world. So we contribute also to prepare so our civilization to be more knowledge-based, to look at facts, to work, to be inspired. And we think it's an opportunity to have a space renaissance. Yeah.
Wow, this is one of the best answers I've heard about regarding resource that we're gonna get there, the human's creativity.
Yeah, and now of course, if you have humans, then also the humans are the envoy, and also they are us going there, and they are going there, and they can tell the story, they can share it. We are on Earth, and also with the new means of communication, we'll be almost there. Actually, I have already brought a bit of my DNA on the surface of the moon, because when we are testing our spacecraft Smart 1, okay, we touch it a bit, we integrate it, and at the end, our Smart 1 mission was landing on the moon, so there is a bit of thing there, but on a symbolic way, it's part of an advance of building a multi-planetary species. So we'll have them around the moon. We will have Artemis 3, there will be on the surface of the moon. Every year we will have a build-up of a mission which will be more and more sustainable, and possibly by 2030 we could have a permanent presence of humanity on the moon. With 10 people on the moon, and possibly 10 years later we'll have 100 people. First baby will be born on the moon, possibly 2040. And in 20 years I plan to retire on the surface of the moon.
Wow. You mentioned the DNA and that your fingerprints are on the moon now. Can you share more about this idea of saving human DNA as a backup plan for the survival of our species?
Yes, so actually we discussed this in the frame of the some community workshop that we had developed with the International Lunar Exploration Working Group. It was a group with different space agencies, industries, academia interested by the moon. This we created in like 30 years ago, and we had a roadmap of things that we could do on the moon with a fleet of orbiter, robotic village, human village, and then some possibly. So I propose the idea that we have developed of having a Noah's Ark on the surface of the moon. You know, the biblical Noah's Ark, but the new version is that you bring also some sample of animals and humanity there, so that in case you have a catastrophe that would eradicate life on Earth, you can have a backup. You can survive in a laboratory there, and then you come back. Now, of course, you cannot bring all the whales, all the humans, so the modern way to do it is also to bring some DNA samples. And then you can develop first some precursor, so genetic laboratory on the moon, showing that you can maintain them and you can duplicate them, and so learn also how life form would adapt on the surface of the moon. There are some challenges in terms, for instance, of the radiation environment, in terms of the partial gravity. So you need to do a significant biology and genetic research to do that. But one of the possible benefit would be that we would have a backup of life on the moon. Now, one ethical question is, with what we do on the Earth, why do we escape? And we think that because we have benefited from this evolution on Earth, we have the responsibility also to preserve the other species. Another question is, which DNA should we bring? And actually, we have made some study where you can trace that we are a mix of DNA from our ancestors.
So Bernard, there is a lot of conspiracy going around the moon topic, right? Was it filmed in Hollywood, the Apollo mission, or did Americans really go to the moon? What is your theory?
Yeah,
and can you dispel this myth?
Yeah, so this is okay. It's quite representative of something which is happening in our society, where we are not looking at facts, and we start to have fake news, and we there are a population which are very sensitive to this conspiracy. So when we launched Smart One, actually, we observed all the Apollo landing sites with our camera, and the journalists asked us, "Oh, did you see the proof that
did you see the step, the footprint?"
And we had to be honest, we didn't see them. And then they started to spin out. They said, no, wait a minute. We didn't see them because the resolution of our camera was only 20 meters. So you cannot see all the module and all the steps. But I have a good friend, Buzz Aldrin, David Scott, they went there and they brought some samples. And at one moment, a very good proof of the fact that the Apollo astronauts went to the moon were given by the Soviet scientists, because they brought back automatic sample from the moon, and they were very similar to the Apollo sample. But of course, the Soviets didn't share this information at that time, only later. But I think this is something more important. It's true that people, they like this conspiracy. So we have really to develop a culture where you teach people to look at facts, to also get a bit of science. And I think everybody should be a bit of a scientist. Everybody should be also a bit of an artist. So we have to help everybody to develop all the dimensions of knowledge and creativity that they can have.
Thank you for this. This is an important one. And last one, if you have had an opportunity to share one message with the humanity, with the whole world, what would you say and why?
This message is recorded from the moon. Yeah, so I have arrived there. And I think we have been developing a vision of what we call a moon village. A moon village is an initiative where we are going to explore and settle on the surface of the moon for the benefit of humanity. And this benefit includes developing some science of the moon. From the moon, you will observe stars or Big Bang, or you will also do science on the moon, biology, to understand how we survive there. we develop new technologies that will inspire as well technology we'll use for this place, but also on Earth. We'll exploit resources, we will develop a peaceful platform, and we are going also to inspire the public and the youth to train, to educate, and we start a space renaissance. So some pillars: science, technology, new economy, so inspiration and peace and renaissance. Now, so this was our Moon Village vision, which has to benefit all citizens of Earth, and then of Earth Moon system when we will be between the two. And more recently, we have also started an initiative that build on that, which is called the Space for All. And this initiative we are bringing now to the United Nations to develop the idea that space for all benefits for Earth, like we do in this conference, looking at Earth to protect the environment, climate change, biodiversity, pollution. So we need space, but also we develop space for all beyond. So in deep space, where we are also going to have this human adventure bringing all these benefits.
Yeah, I really enjoyed this inspiring conversation. Thank you so much.
Thank you, Xenia.